This is a very simple proof for the derivative of e to the x. Okay, so I'm sure that most of you know that the derivative of e to the x is, well, e to the x, that's itself. But how can we prove this? Let's start by plotting 2 points on the graph. The first one is where x is equal to x, and y is equal to e to the x. Our second point is where x is equal to x plus h, and y is equal to e to the x plus h. H is 0.000 recurring 1, so it's extremely small and close to 0. Now we can connect the 2 points together and find the gradient of the line by finding the change in y over the change in x. We can write the gradient as e to the x plus h minus e to the x all over x plus h minus x. It's quite obvious that the two x's on the bottom cancel out, so let's just get rid of those real quick. This leaves us with e to the x plus h minus e to the x over h. Using our knowledge of the laws of indices, e to the x plus h is equivalent to e to the x multiplied by e to the h. So we can rewrite our gradient as e to the x multiplied by e to the h minus e to the x all over h. We can factorize the numerator and leave it as e to the x multiplied by, in brackets, e to the h minus 1. And now we'll separate the e to the x from everything else. This will help visualize the next step a little bit better. If you have a calculator, you might want to use it now. We said at the start that h is 0.000 recurring 1, but for the sake of the argument here, we can simply write it as 0.00001 with just a few zeros after the decimal point. You'll see why in a minute. And since e to the power of 0 is 1, and h is very slightly greater than 0, therefore e to the h is just slightly greater than 1, as shown here. You can go ahead and try this on your calculator. It's quite likely that after you start putting in more than 9 zeros after the decimal point, e to the h will just show 1. In order for this proof to make sense, h does have to be small. However, don't go ham and put too many zeros after the decimal point, otherwise your calculator won't really be able to do this properly. So now we can just plug our values of h and e to the h into e to the x multiplied by e to the h minus 1 over h. This leaves us with e to the x multiplied by a very small value over itself, which can just be written as e to the x times 1, which just leaves us with e to the x, which is what we've been trying to prove from the start. So there you have it, a very simple proof proving the derivative of e to the x. Thanks for watching.